Hello, this is Instructor Rick Powers at Western Technical College, Basic Statistics. Lesson 34, Hypothesis Testing, Two Proportions. Our previous lessons regarding hypothesis testing used a process of comparing a population measure to a standard number. The population measure was assumed to be the standard number in the null hypothesis. Then, if the sample number had a low probability of occurring, that would indicate a difference. In our example, the rate of concussions for the population for equestrian teams was found to be higher than the rate for football teams, since the sample number from equestrians, 11%, was higher than the football number, 7.4%, and that difference was most likely not due to chance. We are now going to consider a similar process, but now comparing two different populations by using two sets of sample data. The previous lessons all assumed that the standard number was set in some way, but now we will assume that the information from both groups comes from samples. So for proportions, we will need two sample sizes, two amounts of observed successes. This will lead to two measurements of sample proportion, or p hat. In symbols, then, we need the following: n1, n2, x1, x2, p hat 1, p hat 2. Also, we need to use the symbol for population proportion, p, also labeled with 1 and 2 for each group. It doesn't matter which group is identified as 1 or 2, in a sense, the process will work either way. But the choice has to be consistent with the software grading system for online problems. So what will the null and alternative hypotheses look like? There are two general options. H sub 0, P1 equals P2, H sub 1, P1 less than P2. Or H sub 0, P1 minus P2 is equal to 0. H sub 1, P1 minus P2 is less than 0. As before, we can have less than, greater than, or not equal to. This is a bit strange, but it does make sense after some consideration. Clearly, if the two groups are the same, then the numbers will be equal. But it's also true that if the numbers are equal, then subtracting the numbers will give a value of 0. Then if the first number is less than the second number, subtracting the first minus the second would be less than 0. Sometimes it's useful to have that number, the first minus the second, so it's good to keep in mind what that means. After constructing the hypotheses, we can use technology to find the test value and the p-value in order to make our decision, just as we did in the previous lessons. End of lesson 34.